Let us look at book 6, proposition 19 of Euclid's Elements. It basically says if triangle ABC is similar to DEF, prove that triangle ABC is to triangle DEF is equal to BC square is to EF square. That is the squares on the corresponding sides. Or what he says is in the duplicate ratio of their corresponding sides. Okay, let's see how we can do that. We know AB is to BC is equal to DE is to EF. Why? Because they are similar. So we are given that these two triangles are similar, and which means this angle is equal to this angle. So the sides about the equal angles will be in proportion. AB is to DE is equal to BC is to EF. AB is to DE is equal to BC is to EF. How did we get this step? Basically, we took AB is to DE as BC is to EF. Okay. Now we find BG such that BC is to EF is equal to EF is to BG. So here we know BC, we know EF. Now we have to figure out BG such that EF has the same ratio with BG as BC has to EF. So let's do that. For that, we take a point and we draw two straight lines. And here we cut off a length equal to BC. So this is equal to BC. Now we cut off EF. So let's see. So this is EF. And again we cut this line such that the segment is equal to EF. Again. Now we join these 2 points. And from this point, we draw a line parallel to this line so that this would be equal to BG. This segment BG, we cut on BC. Now to do that cutting, we might have to extend BC. So let's extend BC. So we end up with a triangle ABG. Now here, because BC is to EF is equal to AB is to DE and BC is to EF equal to EF is to BG, we can say AB is to DE is equal to EF is to BG. AB is to DE is equal to EF is to BG. And the angle included between them is also equal. So that means triangle ABG is equal to triangle DEF in terms of area. BC is to BG. BC is to BG is equal to BC square is to EF square. Statement is based on proposition 5.9. So now that means triangle ABC is to triangle ABG is equal to BC square is to EF square, because these two triangles are proportional to their corresponding sides. So here BC is the side of the green triangle and BG is the corresponding side of the triangle ABG. Triangle ABG is equal to triangle DEF. So we can say triangle ABC is to triangle DEF is equal to BC square is to EF square. So now let's see what happens if I make changes to these triangles. Remember, they are similar triangles. So here, as I change triangle DEF, what happens to BG? The moment I make it equal, what happens? BG becomes equal to BC. And again, if I change BC, and because I have set it up that they are similar triangles, this triangle also changes. So it doesn't matter how you set up these two triangles, triangle ABC will have a ratio with triangle DEF, which the square on BC will have with the square on EF. So that was the proposition. Remember, G is not a random point that I have picked up. I can't move this. I can only move BC, or not move, change. I can change EF, I can change BC. Depending on BC and EF, BG will change. So that was book 6, proposition 19 of Euclid's Elements. That's it for now.